time has emerged as a foundational one. Why watch time? If you look at the user feedback pyramid here, many signals are discrete and sparse. Retention is a binary signal with less than 0.5% coverage. And like and collect is less than 5%. Video completion is cover less than half of impressions. In contrast, watch time is continuous and dense, with 100% coverage across all impressions. It provides a richer, always available target for both ranking and long-term optimization. What's more, I'd like to share an interesting discovery from our daily work. We found that optimizing watch time is most likely to increase DAU. Therefore, we take watch time as the best proxy to move DAU, and this is why we put so much effort into watch time modeling. To be honest, our original purpose of this work is for Xiaohongshu's DAU, not only for watch time improvement. However, modeling video watch time is not as straightforward. We face two key challenges. Through our extensive analysis, we find that the coarse grain skewness and fine grain diversity, coarsely, is super skewed. Lots of quick skips within a few seconds. And the finer grain level is diverse and multimodal. By duration, you can see by modality. And if you can see every user, you will find some are picky and some are patient or accepting. By video, you can have multiple peaks from replays or scene breaks. So what do we actually need to capture? The takeaway is very clear. We need to capture both skewness and diversity across the granularities at the same time. This leads us to EGMM. The idea is simple but very practical. We design a mixture distribution that matches the data's shape. One exponential component to model the heavy mass of quick skips near zero. Several Gaussian components to capture longer watch time segments and multimodal peaks. For each user video context, EGMM outputs the mixture weights and the parameters of each component. In other words, instead of predicting a single number, we predict a full probability distribution of watch time conditioned on the features. This gives the model enough flexibility to represent both coarse skewness and fine-grained diversity. We use three losses during our training. First, the maximum likelihood loss to fit the distribution. Second, an entropy term to balance the mixture weights, which encourages balanced use of components and avoids the collapse into a single component. Third, an L1 regularization term to improve the pointwise estimation. At inference, we just take the expectation of the predicted distribution as the final watch time prediction in our system. But if you need a full distribution for calibration, for simulation, or other policy optimization, it's already there. Here are offline results of our data sets. EGMM achieves SOTA performance with average improvements of around 14% in MAE and 8% in XAUC over some strong baselines. And the curves show that EGMM converges faster and models the distributions more accurately. This is the KL loss curves during training. And specifically, EGMM shows an amazing ability in fine-grained distribution modeling. This picture shows the interaction effects between two users and two videos. And you can see the marginal distribution of two videos and the marginal distribution of two users, which one of them is peak and another is accepting. For the PK user and the multi-peak video, the predicted joint distribution reflects both a higher quick skip weight and multiple peaks aligned with the video's structure. For the accepting user or the same video, the exponential weight shrinks and the Gaussian component dominates. EGMM captures their marginal well and, more importantly, combines them into a realistic joint distribution. In our online A/B tests, EGMM delivered a 0.68% watch time increase. This increasement was all the time we submitted this paper, and in recent months, we continuously refine its design and expand the influence of EGMM in our system. The latest watch time increasement is more than 1%. The KL divergence between the predicted and observed distribution online dropped by nearly 20%. More importantly, the curve below is EGMM's long-term retention effect, and DAU, which shows that EGM not only increases time span, but also boosts the long-term retention. This is not just accuracy, it's real platform growth. We are from real industry sectors, so we emphasize that EGM is not only a solution or public data sets, instead it's designed for real industrial scenarios involving hundreds of millions of users and massive content. Its benefits are remarkably substantial, delivering significant gains in DAU and user lifetime value. And let me also highlight it that the story of EGM does not just stop here. EGM's paradigm extends beyond watch time prediction. We have already seen promising transfers to targets in our system in various industrial scenarios like recommender, search, e-commerce, and advertising in Xiaohongshu. In a nutshell, the paradigm consists of 3 steps. Step 1, just do a multi-granularity distribution analysis. Step 2, choose a general prior distribution that matches the data shape. Step 3, train pointwise prediction alongside distribution alignment. That's all. Thanks for listening. The EGMM code is open source. The deployment is straightforward for any modern recommender system. Xiaohongshu is hiring. We'd love to have you join us. Thank you.
Do you use absolute watch time, such as minutes or percentage watch time?
In this work, we use the absolute watch time regression, but in our industrial scenario, we also use this structure for the percentage or quantile regression. Yes.
Can you elaborate on the reason for employing the L1 regularization objective?
Yeah, that's a very good question. If we just use the maximum likelihood loss, we just do distribution alignment. But we admit that incorporating the distribution alignment will power the pointwise estimation. But if you just do distribution alignment, you cannot get a better pointwise prediction. We use the pointwise accuracy is very important. Yeah.
Okay, thank you. And I also have a question because in your offline experiments, you used one data set actually is not about a short video. It's CICM online search sessions, right?
Yeah.
That data set. So what could be the practical implications of your work to other domains in your view?
Yes, the CICM is not for video, but we have dived in its distribution. Its labels also, its label distribution is not that complex like videos, but also have some multipix and skewness and diversities in this data set. So we use it for our offline evaluation. Yes.
So do you mean that it's also possible to extend your work to the other scenarios in addition to short video?
Yes, it can be aligned to other scenarios.